Hi there, welcome back to my YouTube channel. Are you ready to unlock the power of AWS networking? Today, we deep dive into the world of virtual private cloud, better known as VPC. If you ever wondered how to create your own isolated virtual network within the AWS Amazon Service Cloud or AWS, this demo is your ticket to networking nirvana. Get ready to witness the magic of VPC as we guide you through the step-by-step process of setting up a fully customized networking architecture, securing your resource, and seamlessly connecting to the world outside. Whether you are an aspiring cloud architect or a curious tech enthusiast, this VPC demo will empower you to take control of your cloud networking destiny. Let's strap in, deep dive, and unveil the endless possibilities of AWS VPC together. Welcome to the VPC revolution. What is VPC? VPC stands for Virtual Private Cloud. The primary purpose of a VPC is to provide a logical isolation. You can think of VPC as a gated community in a real world. As you see in a gated community, it is separated from the other areas with a high-raised walls, with a fence, a gate, a security guard who is monitoring who is getting in and who is getting out and keeping a track record of them. VPC provides similar functionality in AWS Cloud. It provides isolation within which you can define your own resources, like you can define your own IP addressing, your subnets, a private or a public subnet. You can define your own routers and then network gateways. It provides a security through features like security groups, the network access control list or NACLs, which basically helps you to monitor the traffic coming in and going out, which we call as an inbound and outbound traffic. We'll study about these features in our next slide, where we're going to have a look at the high-level architecture of an VPC. Excellent. In this slide, we will have a look at architecture of a simple VPC. As you see in the picture, we can already see a couple of elements here. One is region, VPC, internet gateway, subnet, instances, and availability zone. VPCs are regional resource. What I mean by that, VPC can be present only in a single region. VPC cannot spread across multiple regions. If we create a VPC 1, it can only be present in region 1, but not in region 1 and the region 2 at the same time. VPC can spread across multiple availability zones. In this diagram, we see the three availability zones defined: availability zone 1, availability zone 2, and availability zone 3. Subnets are availability zone specific resources, and instances are launched inside subnets. There are two types of subnets that you can configure in a VPC. One is a private subnet, second one is a public subnet. Public subnet has a connectivity to the internet. Any EC2 instances or any workload that you launch in a public subnet can directly talk to internet. That is not the case with a private subnet. For the workload which are running in the private subnet to talk to internet, you need a special device called NAT gateways. NAT stands for Network Address Translation. In the previous slide, we discussed about two security features. One is a security gateway and a NACL, that is Network Address Control List. Security gateways are instance-specific features. It is also called instance firewall. It controls what kind of a traffic that can come into an instance and go out of an instance. Security gateways are stateful. That means we can configure an incoming rule. An outgoing rule is automatically configured. The next element that we're going to discuss is NACL, Network Address Control List. NACLs are subnet-specific resources. It controls what traffic that can enter and exit a subnet. Unlike security gateway, NACL are stateless in nature. In the next slide, we are going to look at how to configure a custom VPC, and also we'll have a look at all the elements that we discussed here and what role it plays and how it works in an actual VPC configuration. Let's go to the demo. Okay, we are in AWS console page. Let's type in VPC and go to VPC page. Here I am, I'm clicking on VPC, click. Okay, now we are in VPC service page. Let's explore what options are available. There's a button, create VPC. By clicking this, we are going to create a custom VPC. As I mentioned earlier, VPC is a regional resources. We need to take care of in which region we are going to create VPC. Right now, the region selected is North Virginia. Let's keep it that way. Let's not change it, right? And on the left hand side, we got a couple of options related to VPC. You can click here and then see what are the VPCs that you have, the number of subnets, route tables, internet gateways, egress only internet gateways, and many other options in the later chapters. Okay, so coming back to the main page, now we can see that there is something called resource by region. As I mentioned, VPC is a regional resource. You need to choose the right region, and then you will get all the VPCs which are created in that particular chosen region. Now, we have not created any VPC so far, but we see there is one VPC here. What is this VPC? Let's click on this. Okay, this VPC has no name, but it has got VPC ID. The state is available. Let's go to the other end of it. Let's see what it looks like, right? So it has got a DHCP. It has got a route table. It's called main route table. There's an ACL, tenancy default VPC. This is the most important thing. AWS, when it creates an account, it creates an VPC by default. That is called default VPC. The one that we're going to create next is called custom VPC. There are some differences between a default VPC and a custom VPC. So the one that you see without a name is a default VPC. Let's create one custom VPC for ourselves. What do we do now? We go to the create VPC page. We'll click on create VPC. Okay, now we are in a create VPC page. We got a couple of options here. It's a basic definition of a VPC. A VPC is an isolated portion of an AWS cloud populated by AWS objects such as Amazon EC2 instances. That's a basic definition that we discussed in the earlier slide. Coming to the next option, there are two boxes, VPC only and VPC and more. Basically, AWS want to make our life simple. So it only giving very few options here for us to create a VPC. But our objective is to explore all that are available for us to create an VPC, right? Let's go and click VPC and more to see what options we get in. Cool. So we can see a lot of information, which was like when compared to our previous options, right? So we got different options on the other side, and we have a visual representation of the different elements that are configured as part of a VPC, right? These are the main components of a VPC. We discussed in our previous slide. It has got subnets, it has got route table, it has got network connection. Let's go and explore each and every option one by one, right? So here we got a name tag auto generation. When we choose auto generation, what happens is like whatever we write, the same name is used as a tag for other resources. Let me type in demo VPC. Okay, so what happened now? So you can see in the VPC, it's called demo VPC. That's the name of the VPC. Now, demo VPC was added to all the elements, whether it's a private subnet or the public subnet, route tables and everything, right? It's called demo VPC-subnet, public one, US East 1A, and then demo VPC subnet, private one, US East 1A. Similarly, for the route table, we can see demo VPC-RTB, private one, US East 1A. So when we choose auto generate option, demo VPC, the name of the VPC get added as a name to all the subnets, route tables and network connections that are created within the specific VPC. This is very interesting feature because it's going to simplify our identification. When we go to the subnet page where all the subnets are listed, we know by looking at the name of the subnet which VPC it belongs to. I strongly recommend you guys use this feature of auto generation so that it makes our life simple in a complex deployments where you have to create hundreds of VPCs for your production network, right? The next one is IPv4 CIDR block. So right now it is chosen as 10.0.0.0/16, which is a default option. You can change it based on your requirement, right? So we keep it default, okay? So right now it also provides you choose IPv6. Basically what happens in some of the deployments, you want to use both IPv4 and IPv6. That's called dual stack, right? EC2 instance that you create will have both IPv4 and IPv6 addresses. Some of the services that you offer might require that, but most of the places where we can stick with just the IPv4 and leave it that. Let's not choose IPv6 to keep our life simple, okay? So that is IPv6. Let's move on to the next option, tenancy. This is very, very important. Let's click here and understand what options are available to us. One is default, second one is dedicated. In default option, underlying networking hardware is shared among multiple customers. For most of the use cases, the default option suits well. But whether there's a compliance requirement, whether there's a strict rules that you cannot share your underlying hardware with any other customer or any other user, then you have to go for dedicated tenancy. For our experiment, for our demo, we will keep it the default. But you have to choose wisely depending on what your use case is and what compliance requirement you have to fulfill. Okay, so that you have to keep it in mind. Coming to the next option, number of availability zone. As we discussed earlier, VPC can be spread across multiple availability zone. It's a regional resources, but it can spread across multiple availability zone. For high availability purposes, we choose two. You can choose one if there's a need, but to make sure that if one availability zone goes down, so our service should not go down. For that purpose, we are making sure that it is deployed in more than one availability zone. So we will be having that in a 2 availability zone. We will click 2, okay? Coming to the next option, number of public subnet. This is purely optional, depending on what your use case is again, right? In many of the use cases, you don't want to expose your workload to the internet. In that case, you don't have to configure a public subnet. You can just live with a private subnet. But in some cases, you want to have a workload which get exposed to the internet. So you want users from the internet connect to your service and then access the backend servers, right? In that case, you need to configure the public subnet. So what happens if I choose 0? By default, it is 2. When I choose 0, just have a look at how things changes on this side of the screen. So let me click 0, okay? Okay, so as soon as I clicked 0, a couple of things changed here, right? So instead of 2 subnets, you got only 1 subnet in availability zone. So we got only private subnet in East 1, US East 1A, and a private subnet in US East 1B. The route table, they got only 2 route tables for private subnets, and then we got like demo VPC network connection. The traffic is not going to the internet. It's not leaving the VPC. It's all within the VPC, right? If I'm going to choose public subnet as 2, you will see some different changes are coming out, right? The moment I choose a public subnet, you already saw one public subnet coming in US East 1A, other one coming in US 1B. And we also see a separate route table popping up, demo VPC RTB public. This route table is associated with the public subnet. Also, there's one new element coming in the network connection that is called demo VPC IGW. This is called internet gateway. Internet gateway is required to establish a connection to the internet, right? Your workloads want to talk to internet, then only you will require internet gateway. When I disable public subnet, the internet gateway got disappeared, but as soon as I add the public subnet, the internet gateway automatically added to the network connection block. Okay, coming back to the next option. Now we need to choose how many private subnets we want to use, right? Again, we can choose 0, 2, and 4. Let's keep it 2. The next one is NAT gateway. So NAT gateways are required for the workload that are deployed in the private network, in the private subnet to talk to internet. Let's assume your workloads which are deployed in the private subnetwork want to talk to internet to download some patches or a new software. In that case, you need to establish a connectivity to the internet. NAT gateway allows workload deployed in private subnet to talk to internet and then download software and patches. So right now in our case we are choosing none because we have no plans to deploy a NAT gateway. We are just trying to understand what are the different elements that we have to configure a custom VPC, right? The next option is VPC endpoints. VPC endpoints allows us to talk to different services of AWS without traversing through internet. As a definition here, endpoints can help reduce NAT gateway charges and improve security by accessing S3 directly from the VPC. By default, full access policy used. We can customize this policy at any time. Let's explore the last option, VPC endpoints. As you are aware, any workload, for example EC2 instance running in the private subnet, if you want to upload or download the data into an S3, it has to make use of NAT gateways, right? It has two concerns. One is cost concern because the traffic has its own going through NAT gateway has its own cost, and also security concerns. Your traffic is leaving the AWS environment and going to a public internet. It can be seen by some malicious users, so you don't want that. So in order to avoid that, to keep the traffic that is going from a private subnet to the S3 bucket inside the AWS environment itself, you can configure S3 gateway. Let's keep it none. Okay, we are pretty much at the end of the page. Now let's explore DNS options. VPC supports two kinds of DNS. One is AWS provided DNS and a custom DNS. In AWS provided DNS, DNS resolution handled by the Route 53 and other services. In custom DNS, you have to configure your own DNS servers and the request will be sent to the custom DNS servers and then that will take care of the address resolution. Okay, let's create a VPC now. Process will take few seconds to a minute depending on the configuration and then the region that you selected. Hopefully it should complete well within a minute. Let's wait for it. Okay, so everything is green, everything looks good. Let's have a look at the VPC that we just created right now. Cool. So we have VPC ID here. The status is available. DNS hostnames are enabled. DNS hostname, the resolution is also enabled. These are the DHCP, main route table, and network ACL IDs associated with the this particular VPC. So this is a visualization of how a VPC works right now. So we got a VPC, demo VPC. It has got like 4 subnets, 2 subnets in each availability zone, and one is public and second one is private. Similarly on US East 1B, and then you can see which subnets are connected to what route table here, right? So the public subnet is connected to a demo VPC route table, which is public, demo VPC RTB public, and then the traffic flows to the internet through a demo VPC internet gateway. For private subnet, this is connected to individual route tables. For example, here the private 1 subnet of US East 1A is connected to demo VPC RTB, private one US East 1A route table, and then both the private subnetworks are connected to demo VPCE S3 network connection. So the traffic that is going to is remain within the VPC. It is not going out to the internet. The only traffic that is hitting demo VPC internet gateway is sent out. So coming back to your VPC, so we got 2 VPCs now. So the demo VPC that we configured right now, let's go and check how the default VPC option looks like for our VPC that we just created. So here it is. Default VPC for the VPC that we just created is no, and then the one that existed previously, it is still yes. So we successfully completed a creation of a custom VPC. With this, we end our VPC creation demo video. If you have any comments, please leave in the comment section. I'll be more than happy to answer them. Thanks a lot for joining and have a good day. Peace. Bye-bye.